Hello students, this is Dr. Saurav's class. We are now doing a problem which we got from our UPSC Mathematics paper, Mathematics Optional Paper. So let me paste the question first. Okay, this is the question. Yeah, then okay. So what the question says us to state the uniqueness theorem for the existence of unique solution of the initial value problem, which is dy by dx fxy, y, then the initial value is y, x naught equals to y naught in the rectangular region x minus r, rectangular region x mod of x minus x naught less than equals to a, and mod of y minus y naught less than equals to b. Okay, then the question has a second part that tells us to test the existence uniqueness of the solution of the initial value problem dy dx equals to 2 root y, y of 1 equals to 0, and in a suitable rectangle R. If more than one solution exists, then find all the solutions. Okay, so for the first term, we can, first part, okay, we have to state the uniqueness theorem. Okay, so it is our, yeah, that color is so, okay. So our uniqueness theorem is Picard Lindelof theorem. Okay. What the theorem test says, we then we have our initial value problem, which is our dy by dx equals to f of xy, and our initial value is this. Now we the conditions of the uniqueness is point 1. Sorry, yeah, okay. So our point 1 is what? The function of fxy is will be continuous in R. In the whole R, the function will be continuous. Then this is the first condition of this theory for, or the condition of the for uniqueness. So and the point 2 says us that fxy, function of xy, have to satisfy the Lipschitz condition. The Lipschitz condition. But with respect to y in R. Now, that there exists, that means there exists a constant L which is greater than 0. So such that for all, we know the Lipschitz condition, right? Sorry, I am writing wrong R. This is only this R, not script R. Script R will be the set of the real numbers. So we are doing this thing in our rectangular region, so it will be R. That's a small typo, and it will be f x y dash minus f of x comma y2 this less than equals to. This is the Lipschitz condition, we all know. And now conclusion. Conclusion is the most important thing for now. Our conclusions is that, yeah, inclusion. And if the above conditions are satisfied, then our if the above conditions are satisfied, then there exists a unique solution y equals to 5x to the initial value problem and which is given, and that is our dy by dx equals to f of xy. I am writing the problem once again. Sorry, this is why not. And valid in some we are just stating the theorem, and then we are drawn the conditions for uniqueness, then we are stating the conclusion now. However, where h is less than equals to a. Okay, then the solution is guaranteed to be unique in R. Okay. Now I'm gonna wipe up this for the second part of the question. Okay. Yeah. Now for the second part, we are tasked to test the existence and uniqueness of the solution for the initial value problem, which is our this dy by dx is equals to 2 root y and y of 1 is equals to 0, and determine where the multiple solutions exist or not. So firstly we have to check the conditions for existence and uniqueness. So we are gonna define our fxy equals to 2 root y. Okay, then for the Picard-Lindlar theorem, existence uniqueness theorem, we have to check that it's continuous or not in our domain. So this they called in a suitable rectangle. Okay, so we can easily see that 2 root y is not defined in y less than 0. In sorry, it will be when we know that. Then after that, but it is continuous. It is continuous in our that part of in our this thing for this part it is continuous. Okay. Hmm. Now for the Lipschitz condition with respect to I, we can check that our, let me change my color first. Yeah, okay. For the Lipschitz condition with respect to I, we can see that our del f del y, which is equals to what will be it? It will be 1 by 2 root I. So 2 cancel out, then it's okay. If this derivative is not bounded near y equals to 0, unbounded near y equals to 0, and as our this goes to infinity, as y tends to 0 plus. Therefore, the Lipschitz condition is violated near y equals to 0. Now, conclusion for existence uniqueness. So, the function fxy satisfies the continuity condition. So, existence of solution is guaranteed. However, since the Lipschitz condition is violated near y equals to 0, uniqueness is not guaranteed. This suggests there may be multiple solutions to the initial value problem. So now we have to solve the differential equation. The given differential solution is separable. as, let me change my color first. It can be rewritten by this, or 2 can be appear at this side. Sorry, let it be. So then what we will get, we know that the integration, okay, the integration will be y and it will be our x plus condition constant. So our y will be now x plus c's whole square. So for the initial value, initial condition, we have our y of 1 is equals to 0. Then what will happen? Then our y of 1 is 1 plus c's whole square is equals to 0. Then our 1 plus c will be 0. So our c will be minus 1. So thus one of the solution is our y, sorry, yeah, let me again change my color. Okay. So our one solution we got, which is our x minus 1, y equals to x minus y's whole square. Then we have to find the another solution. Another potential solution is the trivial one, which is our y is equals to 0. Substituting now, if we substitute it in our question, so we will get dy by dx, which is equals to 2 into 0, that's equals to 0, so which is valid. Thus y equals to 0 is also a solution. So now we are setting up our general set of solutions, which is y equals to our, this color is so vibrant, I like it, as 0, it will be x less than equals to 1. This represents all possible solutions, demonstrating that more than one solution exists, it's violating the uniqueness property. So it has more than one solution, but the uniqueness is violated here. Okay, hope you understood. Thank you guys.